just in case. And okay. So I guess we'll get started. I should have Tosa guys joining us like pretty soon. But so what I don't know why there's so many technical difficulties today, this morning. We okay, this is working. Okay, so I think that many of you guys have questions with homework just before I came. I mean, when I just came here, like, yeah, please raise it now. Like, what's the
When you
problem?
say black and white, you don't mean grayscale. You mean
A
like
grayscale,
full
yeah,
color.
it's same thing, like black and white is grayscale. You mean like 1 bit? No, I didn't mean 1 bit. It's just grayscale.
Okay.
Yeah, grayscale. Yeah. Yeah, it's okay. It's yeah. But yeah. Do you try that? I'll just give you a hint. If you use command to grayscale, you are not able to write it because now it's in different kind of format. The easiest thing is just convert it back, and then you can write it immediately. Yeah.
You want us to post both colored and black and white?
Say that again.
You want us to post both colored and black and white, or just?
If you're doing black and white, you just black and white. It's okay. Like it's additional thing. Any other question with the homework? Yeah.
You
Yes.
said you wanted a screenshot of your end. Is that like
Yeah. You can put in a sign and just try the screenshot.
like a barcode or
I don't know how to do screenshot in Windows, honestly. It's actually a page screen.
You can
and
use
Windows screen.
Windows Shift S, I think.
Something like that. Yeah. And okay, so I heard someone say from Tulsa actually. So let's see. Yeah, if you guys have any question in Tulsa, just yell. I need to because the volume is a little bit low. Yeah. So and any other questions? So actually, I received a couple comments after the end of the last class, just telling me that they don't understand anything I talk about for the last 2 lectures. So I guess I appreciate the input, but I guess just you can just interrupt me like when the time you don't understand what I'm talking about, and also like have some concern and question that what kind of languages. We are using Python. If you never heard of that, it's a programming language. So it's like the animal Python. So it's actually it's an extremely popular language, programming language now. Probably like the most popular programming language at this moment. And and I guess if you guys have at this moment doesn't have any experience in programming, you will have a big trouble as this course progress. So you probably need to get back and just try to learn some of this simple. I mean, if you already know C, Java, stuff like that, it shouldn't be hard to learn like Python or like MATLAB. So you can do everything in Python basically, but in some of the assignment, it's like getting pretty low level, just have an image and we have this matrix moving around. You can use Python with NumPy, of course, but if you want to work on MATLAB, that's fine with me as well. So you can do pure Python, or like for some of this assignment, you can do MATLAB as well. But as you can see, we do some of this. For example, the first assignment is just simple open series stuff that you basically just redo what we do in the class. Basically, very simple. I say as assignment, just want to give you guys incentive, just set up the environment. And for those for those kind of assignment, you really need to use Python, right? There's no other ways, basically. Or of course, you can use, if you want, you can do OpenCV plus C++. Is great actually, but for me it's a little bit more difficult. If you just do something simple, but as I said, if you don't really have any much experience in programming, or you think your programming is a bit rusty, it's time at the beginning of this semester you need a little bit time just warm up. Like otherwise, you will get pretty painful afterward. Like because all the assignments is basically programming. Some of them is as simple as the first one is basically just copy paste, but some of them is more challenging. So, but programming is not hard, but like for some reason, like I know not a big population of people actually do programming. Like some statistics said like only 0.3% of do actually do programming. So you guys are in EE and CS, I guess the percentage is much higher. So any other questions? Again, like before I would jump into the supposing in my first class actually, because I let's see. Oh, I don't know what's wrong with my laptop today. I cannot actually. I have some slides and like I was thinking to go through some of them at the beginning, but then like it was much more fun to just start with like codes and stuff like that. But anyway, like I guess we can go through 1-2 class like. But I probably go pretty quickly with the slides or something, like just go into something that looks a little bit interesting. Some of the slides I just borrow from online, and they capture some of this is pretty nice in terms of human illusion of them. Like, I guess you will find that interesting. This supposing it to be the first class really. So if I hope it's not too late for you to drop it if you, after this class you realize this is not the course you're supposed to take. Anyway, this is logistic things, and as I mentioned, the office hour is kind of not so fixed. Like say from end of this kind of like class up to like 4:30, like I will be around in the Longman campus basically, but you need to catch me by reservation. Most of the time I will be in the library, but and occasionally I guess not really often. Like I may teach from Tulsa, then I guess only 1-2 class like that. Most likely it's like for you guys a presentation, then I may not be here. I think because if you remember, like for the graduate fellows, like some of you guys take the graduate session, you have some additional tasks to kind of present to all of us, like some of these recent development or any kind of research you are interested in related to like computer vision. So and for some of those classes I may not be around, or like because there's also fellows kind of presenting from Tulsa, and for those classes I'm sure I will be there. So and that's in those cases we'll use Zoom. I hope like all of you guys use Zoom before already. That's the new kind of. Do you like it's super easy? Like if you install Zoom, it looks like it support all the platform like Mac, Windows, Linux. So and then you can just watch, and you will get addicted. Once you use Zoom, then you don't want to get out of your home or something. But anyway, so. That's a textbook, but it's not required. I won't actually follow the textbook. It's more like a reference. So it's a good book, and it won't cover everything you're interested in also. And I actually received some of you, I saw some of your posts on Piazza. And, by the way, I'm also like, for you guys, for administrative purposes, like for any questions, like please send to Piazza instead of, unless really personal, for example, you want to join my group or something like that. If you are kind of like sending questions regarding homework, something like that, it's better to just post at Piazza, especially regarding homework. You can include the folder in homework something, right? That will be really helpful to everyone, because others can see your questions, and also like emails is, I keep missing email basically. Like that's just basically too many emails I cannot manage. So I try to can't reply all emails, but most likely I will miss like every once in a while. So regarding the course materials and any comments, something like it's better to put on Piazza. And also let's see. And of course, you know the course website, we have Piazza. If you haven't signed up, be sure you sign up that. Okay, I just mentioned that like several of you like posted a Piazza and show some interest, for example, robotics, SLAM, and so on. We won't get in as far as that, like apparently. Especially for SLAM, is actually, I don't know how many know SLAM. SLAM is like simultaneous localization and mapping. So it's something you have a robot, you move around, and then you try to both localize yourself where you are and also like at the same time trying to do a mapping. And that one, like we will have some pieces like kind of like required to understand SLAM, but it won't have all the pieces. For example, like you need checking like some of these common filters. So like you will get experience for other courses. Like we won't go as far as those, or like you can use particle filters and that kind of stuff to check your location. Especially like for the SLAM, like there's basically several parts where after you do the kind of like warp localization and mapping, they call this like visual odometry. But then like, if you go through a building, like you will form a loop, right? For example, you explore the entire building, like you have a corridor, like you just get a one trip back, most likely you will be off somewhere. So now you need to do adjustment, like make the whole map to, because what I mean is that okay, let me draw. For example, like this is the real map here. You're moving around. Of course, you don't know where you are at the beginning, right? And like when you move around, it kind of like creates some. Okay, I have a rough map here, right? And then you move around. You create more and more and more, and then you go all the way back and stuff like that. But when you go back to the original place, you may be like off a little bit, like off your real position. Then at that time you need to figure out, oh, okay, actually I was there like in previously. Now I need to fix the whole map. So this is like closing the loop. So this can be, but of course maybe you don't want to get as far as that. Like without closing this loop, it's like called visual odometry. Actually I post another post on Piazza. You can take a look. There's a couple articles. It's pretty kind of like very good summary of like visual odometry, and there's also slides there. If you're interested in work on portrait like this, you can go for that. Like, and I think that would be fun. And but as I mentioned, we in the class we won't go as far to teach like visual odometry completely, but we will have some of the elements. For example, you need some kind of like realize these feature points and in the scene, for example, sieve and this kind of stuff. Like some of this technique we'll mention. And I'm also like with TA is also in TOSA, but if you post stuff in Piazza, like he can see it. So therefore, like it's better to post it on Piazza. Either I can see it or he can see it. And as I mentioned, requirement like. The linear algebra and vertical, it's not really that much. I put it there anyway. It's nice to know some linear algebra, so you may get a little bit rusty, don't know what's eigenvalue, eigenvector, but at least hopefully you know like you kind of like you know how to multiply matrix, some stuff like that. Also for calculus, at least I want you to know like how to do the simple derivative, right? Like dx squared with respect to dx will get you 2x, stuff like that, like some simple stuff. Then for whatever more complicated, we can just try to remind all of you, or like remind me also, because I don't always have all these things on top of my head. And actually, this is a question I also like. I'm not so sure like what's computer vision, but it's computer and vision. Vision is the perception of vision. It's not vision 2020, of course, but it's basically you have the perception. You have sensor getting like artificial sensor, not human sensor. So you get like typical cameras, and you get perceive the light. And then try to do processing to get some outcome. I guess that is like what I will interpret computer vision. And of course, like for researcher, like what areas they are researching. Like for example, you go to like big computation conferences, like for example CVPR, and like what they will be interested in and consider as like current research for computation will vary like over time. For example, like as I mentioned, like to some students, like in the 80s, for example, like image processing probably considered as like computation state of the art. But now like no one consider that, and also something like imaging, like maybe at some point like people consider this is like computation, like have some 3D reconstruction, and in particular like CT or like medical imaging, and now mostly they fall into like other disciplines, like they have like a separate disciplines of imaging, and computation is more like you have sensing and then do the interpretation, like try to interpret stuff. For example, you have this image, try to figure out like what's this image is trying to tell you, and okay, let's. And I guess I for this part, like most of you should already know that like what you see for an image is just a matrix, right? So matrix, or basically matrix, is just a two-dimensional arrays, right? So for grayscale image, so like or like I call it black and white here. So for example, like this image is basically just a two-dimensional. Of course, this is a very rough interpretation of this. Is not really this. This has a much higher resolution than this guy here. This just arbitrary. This maybe this, I don't know what's the resolution. Probably like maybe 300 by 200, stuff like that, like roughly. So therefore, like you have what, like 300 by 200, like at least 60,000 like elements there and samples there. It's actually pretty high dimension, and so then like if you think of this, you just have a high dimensional vector, like high dimensional things representation, and you try to figure out like something like all of that. Something is easier for human, something is like like for computer, something is like easier for human. Nowadays like algorithm is getting much better, like especially you have deep learning, stuff like that. Many of the tasks is getting pretty well, like especially for example, like for just some simple image classification, like actually like those like neural network methods algorithms are doing almost as good as human, or if not better. And so as I mentioned, therefore like what is being hard is like keep changing. Okay, this is a fun one actually. Like, do you know who is at the back of Clinton? Yes, but you look at that more carefully.
It's the same thing.
Yeah. Human perception has lots of kind of I don't know, this shortcomings are really shortcomings, or like it just you need that to process stuff more quickly or more efficiently. But you see, we don't process stuff like pixel by pixel. So that's definitely that's something weird going on. I don't know. I know at least one of you guys studies psychology, also like a major minor. Probably you can think more along those lines. There's another like interesting illustration. So which one is darker, A or B? I guess this is another like very kind of illusion. You may see this before. I guess for me, I will say A is darker. Yeah. So, but of course, one thing you need to remember, realize that like not everyone has same perception. As I will mention later on, like actually, someone can even perceive 4 different colors. Like we can, okay, roughly speaking, like we can see like red, green, and blue, like because we have 3 different cone cells, right? But someone's actually like, if I remember correctly, like even like 14 or 16% of the females actually have like 4 different types of cones. So therefore, like theoretically speaking, like if they can use that, they just see something very differently. But it looks like very few people like even have that like is able to see like, but of course other species, for example, bees, see very differently from what we see. So but anyway, here like it's basically A and B is actually the same color, but for some reason again like so why well, I mean, like I'll keep like showing you some of these guys like throughout this class, some of these stuffs. I think it's like pretty interesting. This is, I mean, like as we mentioned just from the previous two slides, we have lots of defect. I would say like kind of like defect like for our vision system, but also like we're pretty amazing in terms of like recognizing stuff. So for example, this for some reason I guess all of you kind of like can. Okay, what was this? Oops. Blue and red, white thing like in the middle. Yeah. I guess all of you will think that, oh yeah, it should be an American flag. Somehow like we just capture that. Like I'm not sure why. But it's not always correct. Like for example, like what is this guy's doing? Wearing headphones. This is a good one. Like other opinion. Like what is he doing? Talking on the phone. Yeah, it looks like talking on the phone. It's quite looks like a pretty big phone also. But indeed, actually, it's not. Okay, so yeah, yes, but. We basically perceive stuff from context, right? Like the low level part, like the current computer vision, like is doing pretty well, but typically that's the things we mess up, like for the computer vision thing. Like we do lots of I don't know, like we utilize lots of prior knowledge for human, and I think that part is not there yet, like for computer vision. But honestly, it's progress so fast for the recent couple of years. Like I'm not so sure. Like maybe next 2-3 years it will be different. Like I'm not catching. Last year I was a bit lazy. Like then I because I teach another class like, on neural network also. I check like, for example, like what's the progress for example, like for natural language processing. Just a year or two ago, like deep learning was not considered as the state of the art. Like, but then like last 2 years, suddenly have some new models like that. Just have like something again like change the research landscape completely. So so I don't know. Like, but we'll come back to this later on. So I don't think I really need to go through this. It's interesting basically why I studied this. And also like there's lots of job opportunities still, always I guess. And lots of companies interested in that. Or like you can find your own company also. Like just many of these nowadays you can build like simple applications with like some of these neural network model like is quite easy to get started basically, and I hopefully like you can think more like for your final project. Maybe like you can make your final project like and kind of interesting application also. So users like this is kind of dated. Like I won't go like very detail of that. Like this for example, like this 3D reconstruction thing, it's still, yeah, I guess it's still interesting. Like, I'm actually still challenging as well. It's not like it's not challenging. I actually like one of my students are working on something similar. Just want to do kind of reconstruction quickly. Of course, like there's many ways to do this. Like sensor-wise, you can use for example, you can use laser, but also you can use some kind of what's that triangular kind of like two cameras. I just have a camera array and just use the angle to figure out like the precise geometry of the thing you are capturing. And so I won't go a lot into this. There's 3D modeling. Oh, but I guess all of you played with this before, Google Earth or stuff like that. Like, just if you didn't like go into that like visit that like for a while, like I will kind of like encourage you guys to visit this again because they continue to make updates. And several years back when I look at that, I didn't see my home like my home like is like in Hong Kong. Now it's all like 3D models also, like they kind of keep changing that. Like, so it used to be just like flag, right? Like it's just satellite images. And of course like recognizing objects, people, like it's always like anyone recognize this scene like
Terminator.
yeah. I think so, like probably. Actually, I'm not 100% sure as well. Yeah. Yeah. I'm thinking, can it be RoboCop also? Like, I don't know.
No, that's Terminator 2.
That's Terminator. Oh, okay. So,
Understandable.
yeah. So, but actually, like, just several years ago, it's very difficult, but like, now it's like quite doable. You can even like do it yourself, like almost real time. But you need to GPU stuff, like running this, like actually, yeah, you just need to have GPU and you can run this actually real time. Not doing the segmentation though, like, but you can have like a block, just like kind of like roughly saying, okay, this is the car and this is a bike here, stuff like that. And so that's also like more of this recognition stuff. Yeah, enhancement is also like kind of like research area, but I guess you can still publish paper there, but like I don't think it's considered as like very much the core problem nowadays. So and also like probably you will publish to like for example image processing. It's not a bad journal anyway, transaction image processing, but and enhancement, like for example, like you can do like super resolution, and also like this is kind of interesting again. Like it's, I got what should we say? Like you see the how things just methods like from one kind of one paradigm just shift to another paradigm. So I still remember like because it's not long time ago, like less than a decade ago, or like a decade ago, I still actually a little bit more than a decade ago, say we used to have like something called cell processing with like compressed sensing, and at that time it was the state of the art, and have lots of math, like complicated math, and then like suddenly like neural networks coming back. Like neural network was there, always there, like from the 80s, actually even from the 50s. And there's ups and downs for neural networks. Like for example, the neural network winters like in late 80s and also like in around 60s, 70s, and then now it's suddenly just came back completely. And then compare this like previous generation, like as I mentioned, compressed sensing, it was pretty impressive. Suddenly it create like much more impressive result. And this is also like some in painting stuff, like I work a little bit like just now I'm old, like I graduated like 15 years or something like years ago. So just after I graduated, I work a little bit there, like, and I still remember my students work on that. But anyway, like the results was good, but at that time, like those basically it's like using math, right? I guess nowadays the major difference like for the last several years is like we just use data to replace math. So instead of you think of like very nice math model like how this work, we just put in the data, put in a network with enough parameters, just train the network such a way that like it will do the job for you. So that's forensic, like, and it's more like a classic problem for OC. Okay, I think I'm boring you. I see if I can find anything more interesting. Like, of course, we have face recognition here, and object recognition. Actually, many of these problems, like people think is challenging and like lots of applications recognition, but for the last several years, suddenly this problem is almost solved. And for of course, a self-driving car is still something like, I guess it would be a big business, and like it's kind of very much related to computer vision as well. And by the way, like that's a really nice topic. Like for example, like for the graduate students, if you want to present something, like this can be a topic you can talk about. You can talk about Waymo versus like Tesla, for example. But by the way, if you look at the Google solution, actually the Google solution is kind of classic. Like if you look at Tesla versus Google, what Tesla doing is like it trying to do some real computer vision stuff, like cutting edge computer vision stuff, like with lots of deep learning stuff. But Google is doing a more classic, like with lots of like laser scanner, the radar, just like do the sensing, not using as much computer vision, and maybe using more localization, GPS, and so on. And for that, like they all kind of like achieve level 4 like automation, right? But yeah, I don't know. I mean, like I don't know why we don't have it yet. So but anyway, so robot vision some of course medical imaging. But as I mentioned, medical imaging nowadays I don't think like people will consider, for example, reconstruction that is very much the core problem in computer vision. Like they will be like in a different discipline basically. So this slide is okay. Maybe I'll just see like why. Okay, think a little bit why it's difficult. Actually, if you ever think of that, like just think a little bit why it's difficult. First of all, think of the representation we just mentioned. That you have, for example, an image 200 by 300, let's say, resolution, 60,000 pixels, and just 60,000 numbers. Now just think of like the simplest application, like recognition. How if you want to write a program to recognize a cat from a dog, how do you do that? It just doesn't look like there's an algorithm. For example, if you study CS, you always have like algorithm to like sorting, like all this kind of stuff. Like you have think of like, okay, have very nice algorithm. If you dynamic programming, whatever, have a particular problem, okay, I can do this, and then the next step do this, and next step do this. But for most computer vision application, like the problems in computer vision, it just doesn't look like there's a kind of like you can build an algorithm like that. For example, like you say a cat should have like 4 legs and so on, but then you go into a problem, chicken and egg problem. So where's the leg? And how do I know this is a leg? So I need to recognize the leg. So at the beginning, I say you didn't recognize the cat. Then I say like cat have a head, but then now you need to recognize the head. So there's a kind of like infinite loop basically. If you try to solve this like with the algorithm approach, let's say algorithmic approach like that you learn in an algorithm class, like okay, you do a sorting, do a whatever, I don't know. I forgot like what do you do in an algorithm class, but basically everything is very defined, like very precise. Right? You do this and you do that and do that. But here, like basically, you it doesn't look like you have a solution for that. And also, of course, like this is why is so? Because like there's lots of variation, right? If you look at an image, you only have the 2D perception. Like you see, for example, a car, like, but at different viewpoint, you just see very different things, right? And also illumination can be like lots of variation, right? So it can just look like completely different things to a computer, right? From very dark to very bright, it just looks completely different. But it's like maybe it's just same angle and same person, same object, and scale also, and also like there's intra-class variation as well. So I guess I guess the best example is like, for example, chair. You have all kind of chairs. You have like that, some chairs that have wheel there at the bottom, or like you have how do you call this? Like I don't know. I have problem with my vocabulary. Like some have with this at the back, like some doesn't. Like right? And some have different shape, totally different shape, and like size and because we have an abstract discussion of our vocabulary, basically. When we say chair, it actually means lots of different things visually. And motion can be a problem as well. And also like some background cluttering and occlusion. So like you have something like just blocking what you're seeing. And this also showing like there's some ambiguity, like local ambiguity. Like this is not showing here, but just the example we saw earlier, like we have some presumption there, we have some prior knowledge, we assume, okay, this has to be like a cell phone or like something like that, but it doesn't necessary. And yeah, I will just skip this. And also like yeah, this is another example. Like you can say that there's lots of defect in type of vision. Like oh yeah, it's too late to show this. Hopefully, it's not too late to drop this class. If it's not your cup of tea. So, but so as I mentioned, it's like project based, right? So homework is more or less like all kind of programming assignment or like stuff like what we do for the first homework, setting ups and then like just whatever. And so therefore that's basically no test, like there's no midterm, no whatever. That's will be just a final project, like. And as I mentioned, like for the assignment, there's bottom up and top down also. Like top down will be like the first assignment. Like you basically use some library that very quickly, just a couple lines and then get it done. But there's also some assignments actually bottom up, so you get more detail into a particular algorithm, something like that. You may want to, I may want you to implement a little bit of a small piece of that. And for those, then you need to get into detail and some matrix, multiply that, and so on and so forth. In those cases, it'll be easier to use MATLAB. Actually, if you're good in Python, NumPy, it'll be as easy as well. But if you want to write in kind of like more verbose languages, for example, C++, Java, it would be a little bit more painful for those assignment. And as I mentioned, like if you're taking the graduate credit, you expect to do one presentation, say for some research area, and no exam. But for the final project, will be like submitting a report. I guess I will give you some extra credit if you also do a screencast. And there's a rough breakdown of the grading, like the assignment 70%, 30%. And for graduate students, you have the presentation that will occupy 20%. So your components, like grade breakdown, will be a little bit different for the graduate student. And also, like for undergrad, you have that attendance bonus, and grad students do not have that. So, okay, that's it. Like, any questions? Yes.
So what does that 20% come out of? Does it come out of the programming or from both categories?
Oh, no, both categories. So I shrink them in proportion. Yeah.
And you said something about a screencast with
Yeah.
the final project.
Yeah.
What did you mean?
Oh, I mean like just like a video. So for example, so screencast is like actually I'm already doing a screencast here. So I'm presenting and then I'm recording.
Oh, you
and
just
you're-
can like record the presentation.
Yeah, yes, you can record the
Oh.
presentation. Or if you want to do a video, it's fine also. Like if you actually sell cameras and present in front of the video, yeah, and it's fine as well. But that's extra credit. Like I don't make it mandatory, but like by the end of the semester, you think okay, you're a little bit behind, and we want to get some extra credit, and that's a possibility. So, any other questions? So, oh yeah, I almost forgot. That's late points. I mentioned that. So for the homework seal, that basically like fill in Piazza, that one I won't have a late policy for that. But for the other assignment I submit to Canvas, there's an automatic like 5% like late policy like per day. So, but we'll be capped for 10 days. So basically, if you're super late, you still have like some incentive to finish the assignment, but you only get half of the kind of like points there. And that's it. Yeah, that I don't need to talk about that. You know about that. So I mean like yeah, you of course you guys can like for assignment working group is fine, but just don't copy homeworks. Otherwise you don't understand. You won't learn anything. And again, I take advantage of Piazza. Like you can pose questions there, and occasionally, like I may give like, or TA will give a small bonus for like for some very constructive replies, like in Piazza. So just want to give you guys additional incentive to kind of like what's that called, to participate. So this is a very nice kind of I guess summary picture I got like from I guess it's a Andrew Karpathy like in his like course SCS 231N in Stanford. So I guess that's the challenge there. You see, like for computer vision, like it'll be like quite a long way to go. Like for people seeing this like immediately, you can kind of infer lots of stuff. Like it's you will think of there's a practical joke going on, and you realize like okay why I mean like that's I guess it's of course it's not just a computer vision problem, but it's also an AI problem in general. Like some people think of this kind of like artificial general intelligence like I mean for the machine or like computer to really can infer everything like we can infer from this picture, it probably is still like for I don't know, it will be a decade or decades or like I'm not so sure actually. But actually I watched some YouTube video like recently like on existential threat. I'm not sure you guys heard of that like for a kind of like AI thing. Like yeah, I think there's lots of interesting argument on those, and I don't know. Just maybe I can take a kind of what's that called? Oh, I have problem with my language. How many of you think that like this? You heard of this existential threat for AI? It's like kind of Terminator thing, like Skynet, stuff like that. How many of you buy that? like kind of like think that it's like something serious. Oh, okay. Like it's really like you can yes or no. I just want to make sure like you have an opinion for that, right? Yes or no. So how many of you think that yes, like that's probably would be an existential threat for human race as it goes.
Existential threat?
Yeah, something like
Threat to existence?
yeah, or like or like we become slave or something. We can still exist, but I'm more like slave. Or like, but just curious like this. So how many of you think that is kind of like you buy the argument that it's going to happen, or like
That it will happen if we don't prevent it?
Yeah.
Yeah. Yeah,
Oh.
that's 100%.
Yeah, if we're unable to govern our machines, then they're going to govern us. It's simple. Especially once they have their own ability to learn, they no longer need us.
But let's take the role. How many of you think that? Hold your hand. Like, so few? Like, I see. So how about the West? Like all of them, I think that no?
I think it depends a lot on how things go.
Yeah.
So okay, I guess I take the same argument. Like if we do not do anything, so I mean continue with the AI development, how many of you think that like there would be a existential threat? Maybe there's a little bit more. Still?
I mean, I don't see what like we can make a very powerful machine. We can like, but we can't make it think exactly like us. So it will never be like us. Like that's it might be better than like some people thinking, but it will not be beyond the power of the average mind, human mind. So we can't do that because we still like neurologically we still don't understand how this is working. So there are a lot of things that we still don't know. I don't think we can give something like we can give something that we don't know how it works and what it is.
Yeah.
Our biggest problem is that we can't give machines souls to determine between right and wrong. Because once we teach them to do something, they'll do that thing without thinking whether or not that's the right thing to do or the wrong thing to do.
They're just following patterns. Like they're not really doing any
Technically,
thinking. It's just following a code and pattern.
It doesn't have morals, so it's not gonna see if I do this, it's wrong. And if you were to try to give it morals, you could potentially say that it might think that listening to you is wrong. So then if that was the case, it would not do that. So it would eliminate you. See, that's always a possibility when you're trying to make something smarter. Like,
Yes.
if something feel like the person is basically like you want to compare to the person, and you try to make it, if someone feel like they're smarter than someone else, why would they listen to them? It's like they can't help them. They feel like they don't. So the smarter you make a machine, and you feel like it knows more than you, why would it listen to you? It would think what you're saying is serious.
Yes, I guess why do you listen? I kind of like. Yes, actually, any other opinion? I think this is kind of interesting, right?
Well, look, it doesn't have to be an aggressive threat. It doesn't have to be an ominous outright threat. It could be that we relinquish control of our food supply to AI, maybe in 20, 30, 50 years. And then if that goes down and we have no backup, that's an existential threat.
Yeah.
That could be very bad.
Yes.
So yeah, there's a lot of possibility for that.
I think right now we don't have enough regulations for AI on
Yeah.
what front we have to develop it and where we shouldn't develop. So I think we need more regulations in order to keep it in check. So if that doesn't happen, then
Yeah.
It might be like a threat if you just like teach it how to do the wrong stuff without like instructing it like when to stop. Like for example, if you are going very fast and you tell the car to stop, you will die at the end because you'll hit something. So if we do something, if we make a mistake
Yes.
or you're making that,
Yes.
we will suffer at the end.
Mm. Yes, actually, yeah, this is very interesting. At first I didn't buy that much because I look at this. I mean, in the sense, I think like it's not that. But actually watching, I guess I buy some of you guys' point, like because I didn't think that much about along this line, and then I watch
I have
couple.
one thing
Yeah,
to add.
yeah.
So let's say we have an AI program to save the
Yeah.
environment.
Yeah.
Okay, and who is the biggest threat to the environment?
Human
Yes.
beings.
So,
Yes. Yes, I guess but that's the word. Like, the AI algorithm we are always working at this moment is just like we'll give them like a terminal goal, but if it has a really general intelligence, it will try to derive a instrumental goal like along the way, and those instrumental goal we cannot control it, and it can be yeah, that part I didn't think very carefully, but of course I don't know how far we are from that, like because I guess if we have like a really super intelligence that can derive all this like instrumental goal, like it looks like it's still pretty far, but I watched one of these kind of like researcher on YouTube, like he gave a pretty interesting argument. It's like stamp collector. It's just like imagine a stamp collector, like you ask the machine to be a stamp collector, try to collect like as many stamps as possible, and then the first thing he realized that okay, where's stamps coming from? Okay, there's a post office. And okay, that's actually even before that, I know he realized that there's many people already have stamps there. I probably want to scam them, so that I'll get more stamps from them. Then maybe I can send them some email and saying that I'm some prince from I don't know, whatever, like Ghana or something, like stuff like that. And then afterward, he realized okay, they pin it like in some post office or something. Maybe I can force them to print more. And then I can occupy that post office, then I can let them keep printing. And then eventually they realize, okay, the stamp is made of paper, there's carbon and whatever. And it looks like all this fellow also made of carbon. Maybe they can be like the source material for making more stamps and stuff like that. So it looks, yeah. So of course it's not, if it has intelligence up to that point, then I guess it's quite real. But I don't know whether it will be in our lifetime. But yeah, it's kind of interesting. So anyway, I have like 15 minutes left. I don't know how to use these 15 minutes. This is kind of complicated. Oh yeah, okay. Any more questions about the homework? Okay, anyone already finished the homework basically, or like, yes? So, also the grayscale? Okay, so, that's great. So, anyone have problem with like platform, like for example, if you're using Mac, Linux, or like Windows, like everyone is doing? Oh, actually, okay, I forgot to mention, I did a little bit homework, like, for that thing, if you try that for the attendance taker, the previous version, it was 3 times slower. So I managed to speed that up, just install like Ubuntu again, like on that. And by the way, like if you guys use Windows, if you just want to kind of get some exposure to Linux, actually, you can also install. If you're using Windows 10, you can install like Windows subsystem for Linux as well. It's super easy to install, and actually I tried it. It's actually pretty good. The only problem is that it have at the current version it doesn't have access of hardware. So for this course, it's kind of useless, except like if you already have some video stored on your hard disk, and then you can just pay with that. But if you want to directly control your camera and so on, it just doesn't work that way. But if you just want to pay a little bit more Linux, it's always useful, honestly. If you didn't do any Linux before, I really will encourage you guys to do a little bit. It will be good for your job career. Like if you I don't know, look for a job, like Linux experience is always useful. And okay, anyone has problems with your homework? Actually, you tried it and have some problem. Yes.
Is that for attendance taking?
Yeah. Oh yeah. Yeah. Afterward, you can go back. Oh, okay. I probably might. I don't know. That's. I probably should somehow like stop this.
Ask you a question, so trying to move on. If I want to have a set of favorites in every school, a set of favorites
So, any other questions, comments regarding the homework or like anything? Okay, I don't know, like, okay, I guess maybe I'll just stop early. I don't know what to do, honestly. Like, if you guys don't have, yes?
OpenCV, is that been configured? Is that a library file?
No, you install like Anaconda, but you can install using PIP. So after you install OpenCV, I'm sorry, after you install Anaconda, you should have something called PIP. Like, and then you can PIP install that. Yeah.
I can't hear you, you got really loud.
Yeah.
I can wait, I know where to go.
Okay. Do you have a question?
I mean, I'm still like, I'm on ground level with this.
That's it. I was gonna make sure I was. That's fine. Thank you.
Yeah, sure. Yes. Oh yes, I put something on Canvas. So can you just write one page, like what you're doing right now? So to get started, I just want to have. So yeah, I put some.
It took me a while because I have to do a lot of.
I think maybe it means like if you use one, you have to do the other, but you don't have to do them. So,
You just put white on because I so it should be there, but
okay, so this is like a ratio. Is it optional with everything else? So if I have something like this where there's one inside another, I wonder if it has.
I guess I that's no.
So this is optional, but if I use.
I'm looking for just reason.
Okay, then, yeah, I think I get it. It's like, they're both optional, but if you use in most interior lines, you need to include the area of exterior. Like if I wanted to use, I think it's saying if I wanted to use the destination chart, I need the also. But I can use destination without using it.
Graduate? Right now? Support?
I just want to like finish my master's thesis. One
If financial support, unfortunately, I don't have it.
if anything comes up, just
Yeah. Oh, okay. No, it's all already online. Look at campus, there's a link there to my website, and then the website has that's all.
What about your slides? Is that posted?
But I guess not in.
It's all on the website, but you can do too many stuff you can do. Anyway.
Did you get the book for linear systems? That's on a PDF. If you
Ah.
want. I can get it to you.
Wait, what course is it? It's not there. Did I? Okay, maybe I didn't. Okay, let me, probably I didn't publish that. Probably I forgot to press publish again. Try this again maybe tomorrow or something like that.
Okay.
Yeah. Yes.
So do I just refer to this?
Oh, yeah.
Steps?
Yeah, you can follow.
I mean, I'm
okay,
just
well,
trying-
look at this is Windows, right? Okay,
Right,
yeah,
this
this
is-
Windows. This will work. This will work.
Okay, cool.
Yeah,
Okay,
so
so I can
yes.
refer to that.
Yes, actually, yeah, you can, yeah.
All right, thank you. That's it.
Let me know if it doesn't.
All right.
So
Yeah.
just on the homework.
Yeah.
So I'm trying to convert my video to grayscale.
Yeah.
So if I run the code,
Oh, yeah, that's a little bit tricky stuff here. After you choose grayscale,
this is the grayscale.
yeah, it works.
But I can't
You cannot
like, save
wait.
the
Yes, you cannot
video.
save-
I only saved the
Yes,
audio.
you cannot save it because it's actually I would like to talk about it in class, but I didn't mention.
Go ahead.
Everybody left?
What's their problem?
No, I mean like, but we'll next class though. Because this is actually a different format. Think of that like this is like, you have like color image, color video, but you have like, actually each color has one number there, right? So it's actually a different format basically. So therefore like you.
So I should not follow this.
No, it's kind of okay. After you change that to color to grayscale, you use this command, right? The easiest way is that you just do this again, like from grayscale back to PGR.
Okay.
And PGR you can save it.
So it'll still be grayscale.
Yeah, there is still be grayscale because you want to grayscale, and then you change it back basically. Yeah. So you have to, yeah.
So I have to change this to
Yeah, PGR.
AGL?
Yeah, PGR again basically just like each frame like you will repeat to have the same matrix like you did 3 times.
Okay.
Yeah.
What, a 5-dimensional array?
Three dimension. 3 dimension per 5 dimension. I see. You have, well, basically each image you have 2D per color. You have 3 of these images. So this is for one time instant. Yeah.
Okay. And there's one more thing.
Yeah, sure. Yes.
Well, you have the same question.
Yeah, sure.
Well, I don't know about her, but I'm willing to admit that I don't know what I'm doing. I'm an electrical engineer. If this was a microcontroller class and you said figure it out, I could figure it out. But this is just software, so I don't know like what.
Yeah,
OpenCV
this is a really software class because I think a computer have like 2 parts, hardware and software. This is almost pure. It's basically pure software.
And that's great. That's why I signed
Yeah.
up. But
Yeah.
what is OpenCV? Is that, do I need to download that, or is it
Oh,
already
let
exists
me
somewhere?
let me look at. Okay, here, just come here.
Okay.
So go to the course website here. Let's see if I have connection here. Oh, I still have here, or you can just look at the big screen. Let's see. That's why I'm. Let's see. I need a browser.
You're talking about,
Yeah.
so I was about to do that. I just.
I don't know what's going on. Like this morning, my computer just went crazy. Okay, let's see if I can. Okay.
Fully VPN.
Let's see. So there's many stuffs here. I'm sorry about that, but let's just go to and this is getting started. So just put everything together. So it depends on whether you're Windows or Mac. Doesn't matter, or like Linux. Of course, there's many ways to install it, but in 2020, I guess the easiest way is just install Anaconda. You try to install Anaconda. So Anaconda is like just any other software. So after you install that, you need to, on the Windows like that, if you're using Windows 10 or something, like you can just type the command, right? For example, you type CMD, you go to a terminal. So you have something that's similar to the terminal. It's like the Anaconda POM. You type that, then you open something. It's very much like similar to stuff like this. Okay.